Math 148, 10.3, Optimizations in Business and Economics, Part 1. Objectives: to find the absolute maxima and minima, to maximize revenue given a total revenue function, to minimize the average costs given the total cost function, to find the maximum profit from the total cost and total revenue functions or from a profit function. The value f of a is the absolute maximum if, for f of a is greater than or equal to f of x for all x in the domain of f. So in other words, it's the biggest value in this domain. Could be restricted, it could be the whole number line. And then an absolute minimum is just the opposite. It's the smallest value in the domain. So notice for this one here, it's a quadratic, it has no absolute maximum, but it does have an absolute minimum right there. For this one, since it's part of a quadratic, it has an absolute maximum here, and the absolute minimum is right here. The 1, 1 is not. The absolute minimum is right there. And for this next one, here's the absolute maximum, here's the absolute minimum for that function. We have two techniques to determine if a critical point is a relative max, relative min, or an HPI. We can do the second derivative test. A negative means it's a relative max. The zero test, it fails. So then use the first derivative test. If it's positive, it's a relative minimum. So if you get a 0 for the second derivative test, then you do a sign diagram. Or you can just do a sign diagram for everything to figure out what it is. So let's take a look at example 7 here. If the total revenue function for a blender is r of x equals 24x minus 0.04x squared, the sale of how many units x will provide the maximum revenue in dollars? Find the maximum revenue. Well, that means we've got to figure out what the first derivative is. So r prime of x equals 24 minus 0.08x. So r double prime of x equals negative 0.08, which is less than 0. So concave down. Critical point will be a relative max. So in other words, since it's always is negative, whatever my critical point is, my critical number for x, it's going to be a relative max. So if I take r prime of x, set it equal to 0, 24 minus 0.08x equals 0, 24 equals 0.08x, so 24 divided by 0.08 So that means I have 300 equals x. So let's move this up. So to maximize the revenue is 300 units should be produced. So if I did r of 300, I'm going to get 24 times 300 minus 0.04 300 squared. 24 times minus 0.04 So this is R of 300 equals $3,600. So $3,600 is the maximum revenue. So find the maximum revenue if production is limited at most 275 blenders. So in essence, I've got to say, well, we can't do 300. The best we can do is 275. So we need to do R of 275. And I end up with 3575. Oops. So in essence, $25 short of what the R of 300 is. Okay, next page. So go ahead and try this one, pause the video, and then come back. Okay, you should have paused the video, so let's go through and figure out what the first derivative is. So that would be 2200 minus 34x minus 3x squared. So that would be, the second derivative would be minus 34 minus 6x. So we're going to use the critical numbers for R prime, and that would be program alpha 9 quadratic, enter data. So that would be -3, -36, 2200. Oh shoot. I did 36, didn't I? Let's try this again. -3, -34, 2200. So x equals 22, or so this right here, I'm not even going to worry what that one is, because what would the domain of this be? If it's the number of units produced, you don't produce negative units. So it makes no sense. So if we put 22 into here, so R double prime of 22, negative, negative, so that's going to be negative. So that is concave down, relative max. So at x equals 22 is going to get a relative max. So R of 22 so 2200 times 22 minus 17 times 22 squared minus 22 cubed. And we should get 29,524. So now we're going to have the maximum revenue is sale of 22 units is 29,524. So let's talk about average cost. If the total cost is represented by C of x, then the average cost per unit is C of x over x. And notice that gets you C with a hat on top, or a bar. So, example 8. If the total cost function of the product is 250 plus 20x plus 0.04x squared dollars, producing how many units x will result in the minimum average cost per unit? So the first thing we have to do is take this C of x and divide everything by x. So C bar of x equals 250 over x plus 20 plus 0.04x. C bar prime of x, so this is going to become negative 250 over x squared, and then this becomes plus 0.04x, or not 0.04x, but just 0.04. C bar double prime of x equals, well, that's going to be 2 times that would be, well, negative 250 times 2, or let me do it over here. So negative 250 x to the negative 2, that comes down, becomes 500 x cubed. So where is the first derivative equal to 0? So C bar prime of x equals 0, negative 250 over x squared plus 0.04 equals 0. So 0.04 equals negative 250 over x squared. 0.04 x squared equals negative positive. Goes to the other side, becomes positive. And dividing by 0.04, so that'd be 250 divided by 0.04, 6250. So the square root of 6250, and x is going to be plus or minus 79.1. So the negative part not part of the domain. So I'm just going to add a page here. We have x equals 79.1, C bar double prime of 79.1 equals 500 over 79.1 cubed, which of course is greater than 0, which is concave up, which implies a relative minimum. So this tells me that the 79.1 is the correct value. And then to get the average cost, I need to do C bar of 79.1, which is going to be 250 over 79.1 plus 20 plus 0.04 times 79.1. So 250 divided by 79.1 plus 20 plus 0.04 times 79.1 gets a minimum cost of about $26.32 per unit. And one of the questions I know people are going to ask, but this isn't a whole number. And I'm going, yeah. But when I say a unit, how many items are in a unit? This is one thing that if we were in class, we'd have a discussion. What does it mean when you say a unit? For example, if you say a unit with terms of pallets, then you're talking a pallet of items. and that can have how many cases of like green beans or radios or whatever is on that pallet. That's 1 unit. So 0.1 unit means, 1/10 of a pallet. So it's very possible to produce that many. Now, shipping it would cost more because you're not doing a full pallet, but you're starting to get the idea, when you start saying, well, I want, 79.1 truckloads of something, okay, or containers of something. All of a sudden, 0.1 containers, that's a lot of product still. And it could be, it's like, well, you're having individual items, then 0.1 won't make sense. So you either produce 79 or you produce 80, and then you figure out, well, which would cost which. So again, depends on the situation. So take a look at the next page. I'd like you to do this one. So again, pause the video, work on that, and find the minimum cost. Okay, you should have paused the video and be done. So let's clear that out. So we're going to have a fresh calculator there. So divide C of x by x. So that gets me 49 over x plus 2 plus 0.01x. So the first derivative is minus 49 over x squared plus 0.01. So this is going to be 98 over x cubed. So where does c bar prime of x equal 0? So that would be negative 49 over x squared plus 0.01 equals 0. 0.01 equals 49 over x squared. So x squared equals 49 over 0.01. So x squared equals 4900. Take the square root of that, and you're going to get x equals 70 or negative 70. And of course, the negative 70 isn't going to make any sense. You don't produce negative units. So now that we have 70, c bar double prime of 70 equals 98 over 70 cubed, which is greater than 0. Concave up, relative min. So c bar of 70 equals 49 over 70 plus 2 plus 0.01 times 70. So 49 over 70 plus 2 plus 0.01 times 70, which gives me 3.4. So this tells me the minimum average cost is $3.40. So try this one. Again, pause the video, come back, pause the video, take the first, second derivative, do all the work, then come back and watch how it's done. Okay, so if the profit function of a commodity P of x equals 1440x minus 2x squared minus 1/3 x cubed minus $15,000, selling how many units x will result in the maximum profit? Find the maximum profit. So first thing we got to do is take the first derivative. So that'd be 1440 minus 4x minus x squared. Taking the derivative of that gives me minus 4 minus 2x. So p prime of x equals 0. So that would be negative x squared minus 4x plus 1440 equals 0. So quadratic, negative 1 -4, 1440. Option 2, roots. So x equals 36 or -40. Of course, the -40 is not in the domain, so throw it out. So p double prime of 36 equals -4 minus 2 times 36, which is less than 0, which gives me concave down, which implies a relative max. So p of 36 so 1440 times 36 minus 2 times 36 squared minus 36 cubed. Then I'm going to divide that by 3 to get the 1/3, minus 15,000. And I'm left with 18,696. So that's the maximum profit right there.